Hey everybody, I'm really excited to be here with you, and I hope you're doing great. So far, we went over some terminology and syntax associated with classes. Then, we dove a bit deeper into libraries, solving a real-world problem with the servo library to kind of see how these things work. This time, we're going to take a closer look at classes and what they're made of. Before we delve into that, let's do a super quick review on some key points. Remember that classes are libraries, and they contain both functions and data. The data are referred to as data members, and the functions are called member functions. The class definition is sort of like a blueprint or a cookie cutter, and the objects are like the house in the blueprint or the sweet treats the cookie cutter punches out. We know that to create an instance of a class, which is also called an object, we need to call the constructor, name the object, and pass it any attributes if it takes any. But why do we want to use a class in the first place if we're not making a library? What's the point? I mean, we have functions we can just copy between programs and use again, right? Well, rather than copying multiple functions between programs or sketches, classes allow us to wrap them all up in one neat package. And this is one of the fundamental concepts in object-oriented programming, or OOP. Now, with this lesson comes a few more words on terminology and syntax. I know, some of you are probably groaning, saying something like, hey, but we covered this stuff in an earlier lesson. And indeed we did. And we'll see a lot of the same terminology and syntax we've seen in the past few lessons. But I'd hate to see you infected with information overload. So I want to introduce terms and other information as needed, just in time. And to make this lesson a bit less painful and more exciting, we're going to start by actually dissecting the servo library we used in the last lesson, and look at the class that makes the library up under a magnifying glass, hitting on the important parts. Alright, so let's go ahead and do that. So here we can see what's called the class definition from the servo library. And there's more to the servo library code, but I just copied the part we're going to be concerned with and pasted it here. Now, the class definition has two parts, the declaration section, which is the one we're looking at right now, and the implementation, which we'll get to after we talk about the declaration. So, let's dive into the declaration section and take a look. First, notice we have the word class followed by a space, then the name of the class, which in this case is just servo. Next, notice the curly braces that enclose everything else, and the semicolon after the last curly brace. Now it's time to talk about that new terminology and syntax we mentioned. Notice we see the words public and private followed by a colon. These are the two main parts of the class declaration, and the names of these two sections strongly suggest their purposes. In the public section, we see a list of function prototypes for functions that are visible and usable to other functions and parts of the programs. And this is why the public part is also known as the interface of the class. It's the public-facing part of the class that contains the stuff other parts of your program will use. And as a quick side note, one of the fundamental principles of good software design is to separate the interface with the implementation, which we'll talk about next. Doing this makes it easier to modify programs and has a lot of other benefits. Now, we talked about function prototypes before, and back then I said they were optional. However, here we need them. So if you want to review the lesson on function prototypes, please go back and do so. Notice the first function prototype. This is the prototype for the constructor, which is a special function we've talked about before, and we'll say more about the constructor in a bit. We can also see prototypes for all the other functions involved with the class, some of which we recognize from our last lesson, like the attach and write functions. Also, notice the comments. It's okay to use comments in class definitions, and, like using comments elsewhere, it's good practice. Next, we see the private section. This section contains variables and sometimes functions that are available only to the class itself, so they're hidden from other parts of your program. If you recall our lesson on variable scope, this is kind of like that. The scope of the data and functions in the private section is only within the class itself, while the scope of the functions in the public section is similar to variables with global scope in that other functions outside the class can access and use them. Within a class's scope, members are accessible by all the class's member functions and can be referenced by name. Outside the class's scope, class members are referenced through the object we create. So, we wouldn't put functions like attach and write in the private section, because if we did this, the other parts of our program wouldn't be able to use them. Now, some of you may be asking yourselves where the actual function definitions are. After all, we have the prototypes right here, so where are the definitions? Well, I hinted at this before when I said that good practice tells us to separate the interface from the implementation section. The function definitions live in the implementation section of the class. So let's get into the implementation section.